All right, so you have a 3D printer, and your company is Contex.
It is.
Yeah. So this is a 3D printer. Can you explain how that works?
Yeah. So the 3D printing process is quite easy. It's based on an inkjet technology. So we use normal inkjet print heads from HP actually.
Yeah.
So what it does is it prints. First of all, you have your CAD design.
So a 3D design.
So you have a CAD design.
Yeah.
You have a CAD 3D design. What it does is our printer driver, it'll take in the 3D design and cut it into thousands of layers, or at least hundreds of layers. And each layer is then sent to the printer. The printer will print with the binder, a color binder, to a very, very thin layer of powder.
Yeah.
And so each cross-section is sent to the printer, and the layers are printed and put on top of each other. So at the end of the print, you will have the build room going down, putting each layer on top of each other. And at
the same color for example, in the middle of this is yellow, is only on the top of it.
You can have multiple colors. There's no limitations. You can see we can do logos, we can do colors, we can do textures, we can do anything.
But you only color the top of it. Inside is just powder.
It depends on your design, but it depends on the algorithm also. So it'll calculate what it needs to get this kind of color. It'll calculate what it needs to color it. If it needs 1 or 2 or 3 millimeters, typically it's less than a millimeter.
Less than a millimeter of
the coloring part.
Of the coloring part.
Of the part, yeah.
That's the last part of it, no?
I'm sorry?
First you do the whole 3D and then you color it at the end, or?
No, it does everything in one process.
In one process?
Yes.
So you can do all kinds of things?
You can do anything, even movable parts, because this is a movable part. It's printed in all in one. So whatever you design, the printer is the output device of whatever you design. So
it just comes out like this, so you have to...
It comes pretty much out like this. So what happens is, once the print is done, it'll have not printed these gaps, and that's why the model in this case has a ability to move.
But it doesn't just come out. You have to build it like a IKEA piece, no? Or like a Lego? Or
no. This is non-assembled. This comes out in one part.
It comes out like this?
It comes out like this. It's not assembled. So it comes out like this. It's printed. Each cross-section is printed. And due to the parts, the gaps here not being printed, they are movable. So what happens at the end of the print, you'll see that afterwards. Yeah. The powder is sucked out, is sucked away.
Sucked away?
It goes away, but you may have to brush in some difficult geometries. You may have to brush away the excess powder. Okay. So you take that off, and typically
it's a little bit dirty at the end.
Well, at the end you get off we have an airbrush needle. Yeah. So you go in and you take off the excess powder.
The stuff that wasn't sucked out.
The part that wasn't sucked out. So what you do at the end, you will then typically infiltrate it with a super glue. You'll dip it in a super glue, and that seals the surface, makes it hard.
It's hard. Totally hard. It's not breakable. It's solid.
No, it's fairly. It depends on
powder.
No. It's definitely solid.
Solid.
It's definitely solid.
But it's not like pottery or something. It does break if it falls. It breaks. No. I mean, you shouldn't try, but it's quite solid.
It's definitely solid.
Ooh, that's nice.
And this was also made in one, of course.
But it has always the same kind of weight, of course.
Depends on your design, really. You can do it, make it hollow, or you can make it solid.
Oh, you can?
Yeah.
And there's a maximum density?
No, it depends on your design. The printer will print whatever you design. If you make a solid design, it'll print out as solid, which will add to, of course, the amount of materials used, but it will make it a little more heavier.
But it's not as heavy as metal or something?
It's not as heavy as metal, but it'll make it maybe a little bit durable if it's all solid.
So could you just visualize how does it come out of the? How would you? Is it better to print it like this or on the other way?
So typically you print it like this because the z-axis is dependent on the time being spent, and since this is a very, very fast process, the fastest on the market, we print about 2 centimeters an hour.
2 centimeters an hour.
So this would be printed in 3 to 4 hours.
3 to 4 hours.
That's 5 to 10 times faster than any other technology on the market. What it does is it prints out each layer, and once it's done, like this, after say about 4 hours, the powder would be sucked out.
All right. Usually, do you think the companies do that overnight, or?
typically they can actually, what we typically see is it's a design company that would make a design maybe in the morning, do the print, sit together in design teams at the midday and decide on a few designs. They can do multiple prints out at once and then decide on maybe, let's say they decide on they have a red and green and blue and yellow option or big and small. They decide on one, throw the other one away, goes with the next one, do the design, print out overnight, sit together the next day, and decide on a new design. It really helps them in their design path, and it speeds up the design process and the time to market, of course.
All right. So can we try and see a little bit how big is the maximum size and all that?
Okay. So this printer is our new printer. Was just introduced about 10 days ago. This printer has a build room which is limited to 25 centimeters times 20 times 20 in the z-axis. We have a bigger machine that has a build size of 35 times 25 times 20. And so that's the largest machine we have at the moment.
So this fits in, for example, or more than that?
Yeah, that would fit in, and this one also.
This one in the height, it fits in?
In the bigger machine,
yeah.
So what happens, as I explained, the excess powder goes away, and that can be 100% recycled. So it's a very, very cost-efficient method.
Right.
So
but how do you cool it down, or you make it hot, or how do you make it solid?
When it's done printing, it typically dries in there for about 60 seconds. 60 minutes.
60
about
minutes.
An hour.
Yeah.
And after that, it's ready to be, after treated, as I explained, maybe in super glue or something.
You also have some advanced thing like this. So it's going to be very small.
So the typical applications for a printing technology like this is, of course, product design. As I explained already, it speeds up the design process in general of either product designs in MCAD or in industrial designs. But also, of course, architecture, the architectures, or GIS, things like this. We even have an example from medical also, where
you also have mobile designs.
We definitely do. We have lots of consumable. We have lots of consumable electronic companies. That of course make their designs, and due to the early designs that they're able to do, they can actually go out and get confirmation from the customers. They can go out and prepare some different designs and see how the customers react to this.
Which they prefer,
the coolness or whatever is needed. And by this, they get a confirmation on a design at a very, very early stage in their design.
The same day.
Even before they have invested further in their development.
Right.
So
you said something like all companies have this kind of technology.
Almost every company that makes production designs or make fast-moving electronic consumables, they are all familiar with these designs. They either have in-house machines or they do designs at service companies. With us introducing this machine, we are definitely moving forward in our aim and our vision to get this machine into every company as an in-house machine next to their printer and next to their copier, to make printable 3D models as fast available as possible at a very low cost and without any security issues either. A lot of companies that make very nice designs that are based that live from a very, very fast living market. They need to do designs secret and very fast.
Stays in-house.
So it stays in-house, very fast and very cost efficient, and in full color. The only technology on the market that makes full color.
But you said you already had like thousands of customers. You have already produced thousands of these.
Yes.
How many thousands?
Oh, we have way over 3,000 installed base.
3,000. But this is the old model you have installed, no? This is very new, you said.
This is the newest one, came on the market for 10 days ago.
So what is the difference between this and the old one?
So this one is highly automated, meaning the user gets a completely integrated system where the powder, where he's not touching the powder, so to say. It's the filling of the bed, the filling of the machine, the binder filling of the machine. Is all automated. The process is automated. The printing, the setup of the printer, the printing, and the after sucking away the powder. It's all in one system.
When you finished one batch, you have to remove it, or it can remove by itself, and you can print the next one by itself.
Actually, you have to set it up again, and that makes sense also because you want to look into your design and
check it.
And check it. So after the print, it'll take away the excess powder. And it will leave your model in there ready to take out.
Sorry. Printer comes out there.
Material. Das ist spezielles Pulver, ja. Die Technologie steckt in dem Pulver. Kann man das dann auch irgendwo noch weiter verwenden?
Should we just check just a few other?
Yeah, let's do that.
Just to check.
So, these are some of the typical applications for a 3D printer. You can see, let's just start with this one. This is a design that was made just printing out in monochrome. And it's just an example of showing you can actually print out your prototype and treat it after just as you like. We sent this to coloring afterwards, and this resembles the final product. It resembles the final product almost 100%. So it's just one example.
It looks like plastic.
Yeah, this is it actually looks like the final product as a rear mirror. A few other examples. First of all,
but this doesn't come out of your machine. You have to do something on top of it.
No, So this was printed out, and this was then treated, and then afterwards it was sent to coloring. So we sent that to coloring just to resemble an exact rear mirror of a car.
Manual coloring, no?
Yeah, we did that in auto manufacturing. That was just one example. Of course, architecture we spoke about. Obvious architects, architects today use model makers already. They use model makers already, so they are very much aware of the benefits of using a 3D printer because this just cuts down their time of development into almost nothing.
How they used to do it?
They used to finalize a project and then spend about two weeks typically having a model maker make a model manually. By cutting down the printing time of things like this to a few hours, they can actually develop the last 2 weeks up to their delivering of a project. But not only that, a lot of architects and civil engineers, they first of all realize once they get the machine in-house, they now have a basis for a lot better communication internally over the design. Imagine an architect and a civil engineer, they don't necessarily speak the same language. That's the one thing. The other thing is, as I explained already, this can really cut down the design phase of things also for an engineer.
So a lot of your customers are architects?
They are architects, yeah. In this case, it's a neat example of how you can present your next house in a very neat way. You can go in and say, do customization. I need the bathroom to be there.
The customer can take it home and look at it.
Exactly, yeah. They can say, we need the kitchen to be down here, or the children's room over there, whatever.
So how much would it cost actually in powder and all this to print this?
To print this?
Yeah.
I would say that would cost less than €50.
Less than 50? Yeah. So it takes three phases? Or in one phase you can do all this?
This you can do in one print.
One print?
Yeah. This you can do in one print.
So you have to buy the powder and all this from you, right?
Yeah, so the powder and the binder is consumables that comes with the machine that we supply.
You supply for a certain price per packet or something? Packages.
Yeah, we have, as I said, due to the powder being, we can recycle it. It's by
But you cannot recycle when it's finished, no?
No, that's true.
Yeah.
But all the excess powder, all that's not printed. So as I mentioned, it's by far the...
Is this the solution?
The most cost-efficient... the most cost-efficient solution on the market.
1 liter is there?
That's about 1 liter. That's one of the new...
So how much can you do with one of these? For example, over there, approximately.
It's more. It's better described by saying we have a cubic centimeter price of approximately 20 euro cent. So 20 cent, 15 to 20 cent per cubic centimeter, including all the materials, but of course not the depreciation of the machine.
All right. And in which country do you produce this?
So Contex is a Danish company, but these printers and the materials are produced in Boston, US.
Oh yeah. There's a factory over there.
It's a factory over there. The whole printing process is based on a few MIT patents.
All right.
So it has a natural.
So
place in Boston.
MIT kind of invented it, but Contex is distributing and they own the whole thing now.
Yes.
All right. In Denmark, but also the powder is produced in Boston.
It is.
All right. Is a lot of people in the factory?
We have a few hundred over there.
A few hundred working already. So it's going soon enough. It's going to be consumer or not really?
It's going to be consumable.
Like a consumer 3D printer. Is that a little bit far in the future? No.
Well, that is some of the predictions that some of the future consultants talk about. They talk about in every house.
Everybody should have it.
Everybody should have it. Print out their Legos.
Print the Legos.
Or the coffee cups. I think that'll take quite a long time. I think that's 15 years and plus.
15 years.
But the first vision we have, as I explained, getting the 3D printer into every production company in the world, next to their copier and next to their printer. That's the first vision, and that's where we are taking a big step into with this new machine. Architects,
design companies, all this, they have, and approximately how much it costs? It's expensive. I mean, it's professional.
This new machine costs in system price, complete everything included, about 38,000.
38,000.
Yeah.
All right. The whole of this.
That
all
machine.
This.
But we have two other machines in the range of 25,000 and 54,000 euros. So
50, how much?
We're ranging 54,000. So we have a range from 25 up to 50.
3 machines.
Yes.
And one of them is a new one, or all of them are the new ones?
The C printer 450. The mid-range printer is a new one.
Is the new one. All right. All right. Thanks.